Developing an application is no easy task. You've experienced firsthand what it takes to develop one. There are a lot of things to take into consideration. The more complex your app is, the larger the code base will be. After all is said and done, the next thing on your checklist should be to optimize your app. I'm using the word optimize as an umbrella term. It can mean a lot of things. Optimizations can be for performance, speed, size, and developer experience. That last one is equally as important as the others. The approach most developers take is to get their code to work. After the app is functioning, they'll focus on optimization. Part of that is rethinking how your code should be structured. By doing so, your code will become easier to read and manage. Even though it may not benefit the user, it will benefit you. I consider it one of the most important things you can do before releasing your app. I'm not saying you should be lazy when you begin writing your application. Optimization is something you need to keep in mind throughout the development lifecycle. However, you don't want to put yourself in a position where you're focused on optimizing a single section of code for a long time. This could lead you to having to rush other parts of the application due to limited time. Your primary focus should be to get your coding working and functional. After doing so, you can look at maximizing performance and speed. In this section of the course, we will look at how we can optimize the application for everything I just mentioned. A lot of the information presented in this section is experimental. What may work for our project may not work in others. I will try my best to show you some of the challenges you'll face when fine-tuning your app. When you're ready, I'll see you in the next lecture. Oftentimes, registering a component locally is the way to go. If you're using a component in one location, it makes complete sense to register it locally. If the component is used in multiple locations, you may want to consider global registration. Nothing is challenging about registering a component, but we can automate the process if we want to. You may end up developing generic level components, dozens even. To save some time, Vite can automatically register your global components. Performing this task will require a bit of work. Don't worry, we'll walk through every step of the way. First, let's create a generic component. In the Components directory, create a folder called Base. You will want to store global components in a single directory to make it easier for Webpack to find them. We're going to create a component for a button. We'll create a file called button.view. I'm going to scaffold a template quickly. The button component I've created will output a basic button. It doesn't do anything, but I'm creating it for demonstration purposes. After creating the component, let's write the code for registering it automatically. Inside the includes directory, create a file called _globals.js. We can write the code in the main.js file, but we're going to create it in a separate file to make things readable. The globals file will be a Vue plugin. We'll want to register this plugin before we mount the application. Otherwise, the components won't be available globally. Open the main.js file. Inside it, import the _globals.js file. We're going to assign the import statement a name of global components. After importing this file, we'll call the app.use function down below. We'll add the import to the function. Let's review what we'll be doing in order to get components registered globally. The first step is to search for the global component files. We don't know how many components we'll have. The point of automating the process is so that we can register components globally without having to update any additional files. Once we've found the component files, we'll begin looping through them. With every iteration, we'll import the component. There isn't a way to automatically import a group of components. We have to do it one by one. Afterward, we'll want to format the name of the component. It's a good idea to make sure the component names stay consistent. Lastly, we'll register the component with the data we imported. Now that we have an overview of things, let's begin. This file will need to export a Vue plugin. We're going to add the export default statement. Inside the object, we'll add a method called install. We'll be expecting an argument called app. This argument will be added to the function's parameters. In accordance with our plan, we'll start by searching for the files. We'll be working inside the install function. Inside this function, run a function called import.meta.glob. The import.meta object is available in all JavaScript files. It's an object of information related to the current module. Vite extends this object by adding a function called glob. We talked about globs in another sections. Globs are a feature for searching for files with patterns. This function will import files. By default, the glob function will lazy load a module. In our case, we're interested in importing the files immediately. We do not need lazy loading. We can pass in an object to configure the behavior. Let's add an option called eager with a value of true. Enabling this option will force the function to load the modules immediately. As for the first argument, this function accepts a pattern. Pass in the following pattern: components/components/base/*view. We're pointing the function to the directory with our base components. The asterisk characters acts as a wildcard character. This pattern will select any view component files in the base directory. We're going to assign the data returned by the function to a variable called base components. By default, the glob function will return an object of imported files. In my opinion, it's easier to loop through an array. We can convert the object into an array by calling the object.entries function. This function will convert each property to an array where the first item in the array contains the key, and the second item contains the value. Let's pass in the base components variable. Next, chain the forEach function. Pass in an arrow function. In the argument list, let's destructure the array by grabbing the path and module items. The first item in the array will have the file path, whereas the module item will store the component data. It's the same object you would pass into the app.component function. We can use it to register the component. Before we get to that, we'll want to format the name of the component. It'll be based on the file name. To help us with that, we're going to import the Lodash module. Lodash is a utility JavaScript library. It comes with functions that can perform basic operations such as string manipulation. In the resource section of this lecture, I provide a link to the Lodash library. I highly recommend checking it out after you're finished with this lecture. Based on the documentation, it's recommended we assign the import to an underscore character. Vite uses Lodash internally. The Lodash module is already installed in our project. The reason we're using Lodash is because we want to format the name in Pascal case. That can be easily achieved with Lodash. We'll declare a variable called component name. The value for this will be the underscore dot upper first and underscore dot camel case functions. The upper first function will capitalize the first character in the string. The camel case function will camel case a string. We'll be using both functions to get the name in Pascal case. Let's pass in the path variable. The path variable will contain the full path to the file. However, we're not interested in the complete path, just the name. We can grab the file name by chaining the split function with a / character. The split function will break the string into an array. The last item in the array will always be the file name. Let's call the pop function to grab the last item. Lastly, let's chain a regular expression. Pause the video so you can have what I have. The regular expression will remove the extension from the file name. All components will have the .view extension, which isn't what we want. To give you a better understanding of why we do this, let's log the original and formatted name. Then, I'll switch to the browser with the console opened. The original name will have additional characters that aren't desired. The second name is what we're looking for. We have everything we need. We have the component configuration options and a name. Back in the editor, we'll comment out the log statement. At the bottom of the loop, call the app.component function. We'll pass in the name and configuration options, respectively. There's one last issue we'll need to resolve. In JavaScript, we can assign exported values to a name or under the default namespace. For example, in the globals file, we are exporting the plugin under the default namespace. Components are also exported under the default namespace. Therefore, the component data is accessible via the default property. I'll add a comment above to explain this better. As you know, we have the option of exporting a component using the export default keywords. Alternatively, we can use named exports. If the component is exported as a default, Vite will assign the configuration options under a property called default. One last thing, we're going to prefix the component names with the word base. Prefixing your names is never a bad idea. This prefix will help prevent naming collisions with other components. I prefer to use base instead of app because these are generic components. Use the naming convention that makes sense to you. We're finished. This function will automatically register components defined in the components/base directory. Let's test if this works by using the button component. Open the About component. In this component, add the base button component below the heading. After making that change, refresh the page on the browser. The button will appear. We've successfully created a way to register components automatically. Registering components locally or globally is a tricky business. If you have global components, consider registering them automatically to save yourself time. An app that loads fast is something you should try to achieve, no matter how large it is. Another aspect that is sometimes forgotten is the feeling of performance. Let's say we had an app that takes 1 second to load. That's a decent loading time. If we add spinners and loaders, that might give the impression the app is loading slowly. Even if the content loads at an acceptable rate, the perception is just as important as the actual speed itself. Apps need to feel smooth and fast. If you have your content popping in one place, one at a time, it can make it feel slow. That's what's called perceived performance. To illustrate this better, let's look at how the app we developed loads content. View a page for any song in your app. It doesn't matter which. Any will do. If we were to refresh the page, the content loads rather fast. There's not a lot of complex logic going on. Likewise, we're making minimal requests to the database. This is favorable because that means our app will load fast for most users. However, not everyone has high-end machines or high-speed internet. To get a better feel for how our app would perform on other machines, we can use the Chrome Developer Tools. Go ahead and open the Developer Tools. We're going to view the application in the Network panel to help us understand what's going on in our app. This panel will present us with an overview of the incoming and outgoing requests. Another feature of the Network panel is being able to throttle the network speed. This feature can help simulate the speed of slower internet connections. By default, throttling will be turned off. We can illustrate the problem by changing it to a slower speed. I'm going to use slow 3G. If I refresh the page, it'll take longer to load. Each time I refresh, the content popping into place becomes more noticeable. After the page loads, it takes a while for the name to appear. It would be better if the page could load in unison. Fortunately, we can change this behavior by modifying the code to use a different hook. Open the song component file in your editor. we're going to make modifications to the created lifecycle hook. As a refresher, the created lifecycle hook is called when the component has been created. We've made the function asynchronous, but Vue will not wait for the function to finish executing. It'll continue to load the content on the page. This means that the content will load before any asynchronous tasks are completed. This is why we see the component load, but without any content. It's because the data hasn't been retrieved yet. We want the component to load after we have the data in hand. To do that, we'll need to change the hook to a navigation guard. Change this from created to before route enter. The before route enter navigation guard will run before the component is loaded onto the page. One significant difference between this and the created lifecycle hook is that we can explicitly tell Vue when to move on to the next step. If we don't tell Vue that we're ready to move on, then nothing happens. This guard will give us the opportunity to perform any operation necessary for the component to display properly. You'll need to be aware of some issues, but I will discuss those in just a moment. First, let's accept the parameters to, from, and next. The first issue we'll face is that the this keyword isn't bound to the component. If we were to run the code as is, Vue would throw errors because we're trying to reference values that don't exist in the current scope. Keep in mind, navigation guards run before the component is loaded. We won't have access to the data, methods, and anything else injected into components. Luckily, there's an alternative way to get the data we need. Inside the guard, we're making a request to Firebase for the document. We're passing in the ID, which is accessed via the this.route object. Since we've switched to the guard, the route object isn't accessible. We'll need to replace this with the to object. The to object holds properties related to the current route being visited. This object includes the route parameters. We'll be able to provide the function with the information it needs. Afterward, we have more lines of code that uses the this keyword. This is where the real challenge starts. This part of the code needs the data property to be set and ready. That's not possible because the before route enter navigation guard is called before the component is created. Fortunately, we can get around this by using the next function. The next function can be used to provide context to our code. Let me show you what I mean. Right after making the request, call the next function. It's perfectly fine to do this because we don't need to run asynchronous tasks anymore. Even though we've given Vue permission to proceed, a lot of the code we have will execute almost instantly. This code won't work just yet. The next function has an optional parameter. We can pass in a callback function to run after the component has been loaded. We'll pass in an arrow function. The arrow function can have one parameter called VM. We'll add it in. At this point, the component has been loaded. We can access the component's data via the VM parameter. It's a context to the component. We can treat it like the this keyword. Therefore, we can move the code inside the function. We can replace the this keyword with the VM variable. This will produce an error with ESLint because we're attempting to assign a value to a property in the VM parameter. We're going to ignore this warning by adding the ignore comment above it. That'll do it. Save your changes. View the page again with throttling on. Things are different this time around. The speed at which the page loads will be the same. The changes were made to make the perceived performance faster. Unlike before, the content will load with the component. This is, of course, a case-by-case thing. Sometimes it's fine to load a page without some content. For example, we have comments on the page, but they're not as important as the main content itself. It's fine if they load after the component has been loaded. Most users will want to focus on the primary content before reading the comments. Of course, that's entirely up to you. That's just how I recommend you approach things. In this lecture, we're going to learn how to import a component for a route dynamically. I want to start discussing bundle size reduction techniques. Let's talk about the idea of a bundle. Every time a file was updated, Vite would update our bundle. A bundle contains our HTML, CSS, and JavaScript code. The bundle size can get quite large the more logic and libraries we add into the mix. There's even a phrase for being afraid of how large your bundle can get called bundle phobia. It can be easy to let your bundle grow to a large size during the development phase of your application. The source directory is relatively small compared to the modules directory. A lot of the optimizations will be for the modules we're using. However, that doesn't mean you shouldn't also optimize the code in the source directory. In this and the next few lectures, we'll look at how we can reduce the bundle size. One of the simplest things we can do is to dynamically import route components. If I'm on the home page, it is only necessary to load the home component file. By default, all components get loaded, whether they're being used or not. That's not an effective way to load things. It would be better if we could load components when they're needed. We can use dynamic loading to get the desired result. We can instruct Vite to put components into separate files. Then when they're needed, they can be loaded in and still work. This feature is referred to as chunks by the Vite community. Chunks are a Vite concept. They're not specific to Vue, but still important to know. The files in your project are combined into a single file, or at least that's what Vite tries to do. Sometimes you may not want this to be the case. We can tell Vite that we'd like for a file to be processed, but not be part of the core bundle. This is what's called a chunk. Chunks are ideal for files that are requested to make your app functional but don't need to be loaded immediately. Instead, they can be loaded at a later time. Vite will handle separating files for your application. When you need them, it'll help you with this process too. Creating a chunk isn't hard. One of the most common methods of using chunks is for loading route components. I'm currently in the router file. Inside this file, we are importing the components for the routes. We need to do this because the router requires us to register the components in the records. We're going to instruct Vite to convert these components into chunks. This will allow our application to load the components only when they're needed. We can load the components asynchronously. Vite will help us with that. Below the import statements, we're going to create a variable called home. The value for this variable will be an arrow function. We're not going to immediately import the component. Instead, we'll create a function that can be called for importing the component. The return value of this function should be the component we want to dynamically load. We're going to call the import function. The import keyword may be used as a function to import a module dynamically. The data exported by a module will be returned as the value. The import function requires the path to the module we want to import. We'll pass in the path to the home component file. After adding this in, we can safely remove the import statement above. Let me break down the process Vite will go through to import these files. It'll notice that we're using the import function. The file you pass in will be made into a chunk automatically. When the import function is called, it'll load the chunk for us. It's taken care of for us behind the scenes. We don't need to update the route because we used the same identifier from the import statement. Route records will accept functions as long as the function we're passing in will return the component configuration object. If the home route is visited, the Vue router will invoke the home function we created. The home function will call the import function, which will proceed to load the chunk file. I'm going to do the same for the rest of the components. I've removed the import statements for the components. Make sure you do that as well. Once you've made those changes, save your work. Then view the app in the browser. The app is functioning fine. We can switch between pages without a problem. To better understand what's going on behind the scenes, We'll open the Developer Tools Network panel. In the Developer Tools, we're going to filter the results by JavaScript. Chunks are saved as JavaScript files. I'll refresh the page and switch to the About page from the Home page. A new request was logged. The request is for the chunk generated by Vite. It'll hold the component data. That's great. This will reduce the bundle size by not including code the user doesn't need immediately. What's even better is that if a chunk has already been loaded, Vite will not load the same chunk again. This makes switching between pages faster. The chunk gets temporarily cached. That wraps it up for this lecture. We'll continue in the next one. One of the downsides of separating the bundle into chunks is longer loading times between pages. Chunks require an additional request and download from the server. If the user clicks a link, we should provide a way to indicate that the chunk is currently downloading. Not providing visual cues might lead the user to believe that nothing is happening. That can result in them leaving the app. We don't want that to happen. Let's tackle this issue. One of the most effective and elegant solutions is adding a progress bar. In the resource section of this lecture, I provide a link to a library called nProgress. Clicking on the play buttons will trigger the progress bar to appear above. It'll slowly increment until you tell it to stop. Platforms like YouTube implement a similar behavior. Let's add this library in our app. Switch over to the command line. Stop the server. Next, run the following command: npm I nProgress. After installation, we can begin to use it in our app. As you may have noticed, the library is not an official Vue plugin. Luckily, it's not hard to integrate into our app. Here's how we're going to use it. If the user visits a new page, we'll want to load in the progress bar. Once the page has been loaded, we can remove the progress bar. This can be done by using navigation guards. Let's get started. In the includes directory, create a file called progressbar.js. We'll write the code for the progress bar in this file. At the top, import the nProgress module. This module will provide us with the functions for creating the progress bar. The next thing we'll need to do is grab the router object. The problem is that we don't have access to it. We won't be able to use navigation guards without it. We can get around this issue by passing the router object to a function inside the file. We're going to export an arrow function that accepts in the router object. Afterward, in the main.js file, import the progress bar file as progress bar. Below the import statements, we're going to call the progress bar function and pass in the router object. This will make the router object accessible in the progress bar file. Before we add the navigation guards, I'm going to import another file called nProgress.css. The nProgress library comes with styles for the progress bar. Importing the default styles is optional. We have the option of creating our own. I prefer to use the stylings that come with the module. They will fit nicely with our app's design. Switching back to the progress bar file, we're going to define the before each and after each navigation guard functions. The before each guard is called before the route begins to load the component. This is a guard we've used before. It's perfectly fine to call it again. We're allowed to define the same guards multiple times. This makes it easier to separate things. Before every route, we want to initialize the progress bar. Pass in an arrow function that accepts in the to, from, and next arguments. Inside the function, call nProgress.start. The start function is what will initialize the progress bar. It'll take care of slowly incrementing it. We don't need to configure the bar any further. It works out of the box. After the start function, call the next function so that the router can begin loading the component. Once the router is finished loading everything, we'll want to stop the progress bar and remove it. We can do that by using the after each guard. Normally we would create a function, but we can simply pass in the nProgress.done function. The after each guard will call whatever function we pass into it. We're directly passing in the done function. There isn't anything else we need to do, so it's perfectly fine if the router calls this function for us. The done function will force the progress bar to fill up the page. It'll then fade away. You'll notice I'm not invoking the function. If I were to invoke the function would get called immediately. We only want it to be called when the after each guard runs. The view router will invoke the function at the appropriate time. Unlike the other guards, the after each guard isn't provided a next function to call. The route will change regardless of what we do in this function. That's perfectly fine since we're trying to animate a progress bar and nothing else. Let's try testing our new feature. Refresh the page in your browser. Then try navigating to different places in your app. The progress bar loads before every route change. It goes away after the route change is complete. This is the exact behavior we were going for. It appears briefly because we're testing this on a local connection. I recommend testing this out with the throttle on. That'll give you a better feel for how this will behave in a real environment. In the next lecture, we'll continue with optimizing our app. In this lecture, let's explore one of Chrome's tools for helping us optimize our project. So far, we've been using solutions curated by Vite or third-party packages. While they were helpful, they didn't paint the full picture. There are other tools available that can help us monitor the performance of the app we're building. One of those tools is called Code Coverage. In this section, we will talk about what that is and how it can help us. Earlier in the section, we learned how we could split the bundle into chunks. Writing components in separate files meant that the user didn't have to download them on every page load. If they weren't going to be used, then they don't need to get loaded. The challenge we face with this is how do we know which code should stay or be put into a chunk? One solution is to use the Code Coverage tool in Google Chrome. The Code Coverage tool will tell you in real time which parts of your code aren't being used. This tool will narrow down what can be left out in your code base. Using the Code Coverage tool is rather simple. Open the app in your browser. Then, open the developer tools by pressing F12 on your keyboard, or the Command, Option, J keys if you're on a Mac. At the top right corner, there will be 3 vertical dots. Clicking this will open a menu. Select the Console Drawer option. The console drawer is an additional set of tools for debugging your application. They're rather simplistic, which is why they're not included with the developer tool's default set of panels. It may look like it's just another console, but there is more you can add to the drawer. At the top left corner of the drawer, click on the dots. Select Coverage. You'll be prompted to begin the recording process. The Coverage tool doesn't actively monitor your app unless you tell it to. Press the Record button to begin the monitoring process. Some files may appear, but we'll ignore those for now. We want to start with a fresh list. Refresh the page in your browser. After a while, a fresh list of files will appear. The Coverage tool will output a list of files being loaded on the page. It'll detail information such as the size. More importantly, it'll tell you how much of the code in each file is being used. A visual will even be provided where the color blue is used to show how much of a file's code is being used. Red is used to indicate code that isn't being used. Generally, you will want the bar to be heavily blue. If you were to select the file, the developer tools would switch to the source panel. This will output the file's source code. Before we get to this, there is an additional tip I want to give you. The Coverage tool will only record the current page. While it's still recording, I recommend going through every page as a whole and individually. As a whole because you may have dead code that's never used. This tool can help with determining what you should be importing. Individually because that can help determine what files can be put into chunks. In the source panel, the contents of the file we selected will be displayed. To the left of the line numbers, Chrome will color which parts of your code has been used. Blue indicates used code. Red indicates unused code. One important thing I want to highlight is that sometimes conditional statements will get marked with red. It's perfectly normal for conditional statements to be marked in red since the conditions have to be met in order for the code inside to be executed. You will never usually achieve 100% code coverage in your app. The important thing is that you try your best to optimize every part you can. By using the code coverage tool, it's easier to spot what can be put into chunks. In this lecture, we're going to look at an awesome tool for reducing the bundle size of an application. Personally, it's one of my favorite tools. I'm referring to a tool called the Rollup Plugin Visualizer. In the resource section of this lecture, I provide a link to this package. This package is a plugin for the Rollup Bundler. We're using Vite, not Rollup. Behind the scenes, Vite uses Rollup for building our projects. Therefore, plugins compatible with Rollup are compatible with Vite. We can borrow plugins from the Rollup community. This plugin will produce a UI for analyzing a bundle. It'll give us a better idea of how large your project is. Let's try using it. Switch over to the editor. In the command line, run the following command: npm i-d rollup plugin visualizer. Next, open the vite.config.js file. We must configure the plugin with Vite. At the top of the file, import a function called Visualizer from the Rollup Plugin Visualizer package. Rollup plugins can be registered like Vite plugins. Scroll to the plugins array. At the bottom of the array, call the Visualizer function. Just like that, the plugin will produce an HTML file for viewing the bundle size. However, the HTML file will not be opened in our browser. We can force the file to be opened by configuring the visualizer. Pass in an object. In this object, set the Open option to True. We're ready to launch the plugin. This plugin does not run during development mode. It's exclusive to the build mode. Let's switch over to the command line. Build the project with the npm run build command. After a few moments, a new tab should open in your browser. We're presented with an overview of our project's bundle size. This type of chart is referred to as a tree map. Admittedly, it doesn't look like a tree because it's a bunch of rectangles. Tree maps display a hierarchy of data. In our case, the data are the packages and files in our project. If you've never read a tree map before, that's perfectly fine. Reading a tree map is simple. At the top left corner, the smallest files are presented on the tree. At the bottom right corner, we can find the largest files in our project. In most cases, you will want to focus on the larger files. As you can see, the Node Modules directory takes up most of the bundle size. Strangely, the Lodash module takes up a lot of space. If you think about it, we're not using it heavily. For example, we can hover over this package to view where it's being used. The size of the package is 0.5 MB. The bundle size should be smaller since we're using 2 functions. Let's try optimizing this package. Open the globals.js file. In this file, we're importing the entire Lodash package. Rather than importing an entire object, we should import specific functions. By doing so, Vite will only bundle the functions, not the entire object. Update these lines of code to import the camel case and upper first functions, respectively. After doing that, let's try building the package again. In the command line, run the npm run build command. This time, things are different. The Lodash module isn't taking up as much room as it did previously. In fact, you probably won't be able to see it if you're zoomed all the way out. As I stated earlier, files that take up the least space are placed in the left corner. If we look closely, the Lodash package can be found at the bottom left corner. According to these statistics, the size has been reduced to 25 kilobytes. That's a massive reduction from the full size, which was 500 kilobytes. By changing 2 lines of code, we were able to achieve this reduction. We're finished with optimizing the application. The process is basically the same for all modules. Search through the code and import only what you need. By limiting what you need, you can reduce the file size of your bundle. Be sure to read the documentation to make this process smoother. It'll make things less tedious. Before moving on, I recommend commenting the visualizer from the configuration file. We do not need the visualizer to be active. Remove it from the file before proceeding to the next lecture.